Welcome to Spring LIB.
We are given that the diameter of the cookies is 8.50 plus or minus 0.02 centimeters, and the thickness is 0.050 plus or minus 0.005 centimeters. Hence, the maximum value the diameter could have is 8.50 plus 0.02, which is 8.52 centimeters. And the least value it could take is 8.50 minus 0.02, which is 8.48 centimeters. This is the maximum. This is the minimum. Similarly, the thickness maximum would be 0.055, whereas the minimum would be 0.045. Now, let's find out the volume in part A. We know that the volume is area multiplied by height, which is pi. Area is pi r square and radius r is d by 2, and hence the area would be pi d by 2 square plus multiplied by h. H, the height. Hence, let's first find out the values with the means, that is the central values without the errors. The area would be pi, the diameter would be 8.5 divided by 2 squared multiplied by the thickness or the height t, which is 0.05. This turns out to be 2.8372 centimeter cubed. But our thickness is only given up to 2 significant digits, and hence we express our answer similarly. It becomes 2.8 cc. Now, let's find out the maximum possible volume prone to these errors. We want the d by 2 square to be as large as possible and t to be as large as possible. Hence, we'll take the maximum values of both diameter and the thickness. Hence, the volume max would be pi by 2, and the maximum value of diameter would be 8.52 divided by 2 squared, and the maximum value of thickness would be 0.055. This turns out to be 3.1 centimeter cubed. Of course, we have rounded it down to 2 significant digits. Now, the minimum possible volume would be when the diameter and the thickness are as small as possible, which is their minimum value. Hence, we write pi multiplied by 8.48. I'm sorry, I took out the 2 here. I accidentally wrote a pi by 2 instead of pi. 8.48 by 2 whole squared multiplied by 0.045. This turns out to be 2.5 centimeter cubed. Now we can see that the difference between the V max and V is 0.3 centimeter cubed. Similarly, the difference between V min, the minimum volume, and the true volume is again 0.3 centimeter cubed. Hence, we can write our answer as volume is 2.8 plus or minus 0.3 centimeter cubed. Now, for the next part, we need to find the ratio of diameter and thickness. Now, using the central values, we know that our diameter is 8.5 centimeters and our thickness is 0.05 centimeters. This turns out to be 170. Notice that because diameter and thickness have the same units, which is centimeter, our ratio will be unitless. Now, we want to find, let's call this ratio R. We want to find R max. the maximum value this ratio could possibly take. Let's make this a capital R. Now for the ratio to be maximum, we want d to be as large as possible and t to be as small as possible. Hence, we use d max divided by t min, unlike the last example. Hence, this would be 8.52 divided by 0.045. This turns out to be 189.3. But again, because our t has only two significant digits, we round it to 190 with two significant digits. Now, our R min, the minimum value of the ratio, will be achieved when we take the minimum value of the diameter and divide it by the maximum value of the thickness. This turns out to be 8.48 divided by 0.055. This turns out to be 158.2, which, 154.2, which when rounded out to two significant digits turns out to be 150. Now we can see again that the difference between the ratio and the maximum is 20. And the difference between the mean value and the minimum is also 20. Hence, we can write our ratio as 170 plus or minus 20. This is our answer.